Hey guys, we're going to look at some special cases here with factoring. So perfect square trinomials and a difference of two squares, these are very important in all of your math classes. They're going to be important come EOC time. They're very important on ACT. These can save you a tremendous amount of time on the ACT. We have 60 questions in 60 minutes on the math portion. So please try to commit these to memory. It will make a big difference. All right, the name it kind of tells you exactly what it is. So a perfect square trinomial. Okay, a trinomial, 3 terms, perfect square. It's got perfect square on the front and the back end. So the first and last term are perfect squares. Perfect square trinomial, okay? So when you have this, the middle term is going to be twice AB, and it goes straight to factored form A plus B quantity squared. Same thing with the difference. You go to perfect squares. It's got a minus in the middle. It goes straight to factored form as A minus B quantity squared. Okay, you just have to recognize that these are perfect square trinomials. All right, a difference of two squares. Again, the name tells you difference means subtraction. Difference of two perfect squares. A squared minus B squared. Difference of two squares. That results into A plus B and A minus B. So let's see how these work with some problems. All right, so if you know those, you should be able to look at this and say perfect square, difference of squares, and you should be able to say 2x plus 3 and 2x minus 3. Now, where did I get this? Well, this squared is this, and this squared is this. So A is 2x, and B is 3. All right, this is a perfect square. 1 is a perfect square, so this is going to be a binomial squared. So I know it's going to be 2a plus 1 squared. If you twice AB, 2a times 1 is 2a times 2 is 4a, so that gives you your middle term. Again, you want to be able to look at these and go straight to the answer, especially for ACT, which is the most difficult timed test. The EOC is timed as well, but they're usually pretty generous with the time on the EOC. All right, let's see. Let's clear this. All right, let's look at a couple more examples. All right, perfect square. Again, I can say 2x plus 5 is squared. Twice the middle term, so this is 10x times 2 is 20x. This fits perfectly into the perfect squares. This is a difference of two squares. This is easy to recognize too because this is a perfect square trinomial, 3 terms, 1, 2, 3. And this is a difference of squares, 2 terms. So x plus 3, x minus 3. Again, if you know the form, you can go straight to the factored form. All right, you can always check those by multiplying them out too, but hopefully those are not too difficult. All right, solve each equation by taking the square root. All right, this is the easiest way to solve a quadratic equation. It's by taking the square root because there's no linear term. If you look, there's a quadratic term, but there's no linear term, no x or no k term. So I'm going to add 7. I've got 3k squared equals negative 12. Divide by 3. K squared equals negative 4. Take the square root to get rid of the squared term. So I'm going to have k equals. Anytime we take the square root, we're going to have plus or minus. Okay? And then the square root of 4 is 2. We got the negative 4, so it's 2i. All right, on this one, I'm going to add 8. So I'm going to have 10p squared equals negative 56. Divide by 10. P squared equals, let's see, that should reduce. What will that reduce to? Let's see, 2 goes into it, so it'd be negative 28. Over 5. I'm going to take the square root of both sides, so p equals plus or minus. Now, this is not a perfect square, and this is not a perfect square, but I need to rationalize the denominator, so I'm going to multiply the top and bottom by 5. All right, so I'm going to have square root of negative. Okay, so when I do this in my head, I'm doing negative 25 times 5. I know that's 125, and then I have 3 on top of that. 3 and 5 are 15, so 125 and 15 gives me negative 140. All right, 5 times 5 is 25. Square root of 25 is just 5. All right, so I need to see if there's a perfect square in 140. Let's see, 4 goes into 140. I'm going to pull out the negative as well. So 4 goes into 14 3 times. And 2 left over makes 20. 4 goes into 20 5 times. All right, and we have P equals plus or minus the square root of 4. Negative 4 is 2i. Square root of 35 stays, and that's over 5. This cannot reduce, so that's my final answer. So that's how you solve by taking the square root. So first you want to get p squared by itself, then take the square root of both sides, and then you have to rationalize your denominator and write in simplest form. All right, let's look at a couple more examples. All right, so this one I'm going to first add 7. I'm going to have 6n squared is equal to negative 3. Divide both sides by 6. N squared equals negative 1/2. Take the square root of both sides. N equals plus or minus. I'm going to have to multiply by square root of 2. I'm going to rationalize my denominator again. So I'm going to have I square root of 2 over 2. All right, this one I'm going to subtract 3. I'm going to have 10n squared equals 383. Divide by 10. N squared equals, oh sorry, I subtracted 3. That should be 380 now. All right, so the 10s cancel, so I've got 38 left. And then I'm going to take the square root of both sides. So n equals plus or minus square root of 38. All right. All right, now we want to look at solve by factoring. Okay, if you look at this, it has a quadratic, a linear, and a constant term. All right, so to solve by factoring, we need to first set it equal to 0. So n squared minus 5n plus 24 equals 0. You can see I put the quadratic, linear, and constant term in order because when we factor, that's what we do. So now we can factor this expression. We've practiced factoring. So I need two numbers that multiply to give me 24, that add up to give me negative 5. So I know that 1 and 24, 2 and 12, 8 and 3, 4 and 6, but 8 and 3 are 5 apart. So I'm going to use 8 and 3. And since my middle term is negative, my bigger number has to be negative. And then I can set each factor equal to 0 using the zero product property. So add 8. And subtract 3. So my two solutions are n equals 8 and n equals negative 3. So that's solved by factoring. Let's try number 10. All right, so now it has the quadratic and the linear term on the same side. So let's subtract the 16 and set it equal to 0 again. Again, once we have it in standard form, we can factor. So we're going to have x times x equals x squared. What multiplies to give me negative 16 and adds to give me negative 6? I know 1/16 and 2 and 8. 2 and 8 are 6 apart. So I'm going to use 2 and 8. The bigger number needs to be negative, which means this one is positive. So I'm going to have x plus 2 equals 0. X minus 8 equals 0. Subtract 2. X equals negative 2. Add 8. X equals 8. So my two solutions, I have no idea why I drew through that, but my two solutions are negative 2 and positive 8. All right, at any point you can pause the video to take notes. I know I'm moving through these kind of quickly, but I only have a few minutes to do a free video, 15 minutes or less. All right, let's look at a couple more examples and we'll be done. So x squared, subtract 2x minus 48 equals 0. Because that was my linear term, that's why it goes in the middle, so that I can factor. X times x is x squared. I need two numbers that multiply to give me 48 and add to give me 2. So it's going to be 6 and 8. And my middle number is negative again, so negative goes with the 8 and plus here. X plus 6 equals 0. X minus 8 equals 0. Subtract. X equals negative 6. X equals 8. So I've got negative 6 and positive 8. All right, last example. So we've got x squared. I'm going to add 14x to the other side, plus 48 equals 0. All right, x times x is x squared. What multiplies to give me 48 and adds to give me 14. Well, 6 and 8, the difference of that gave me 2, but 6 and 8 added together give me 14. So I'm going to do 6 and 8 again. This time they're both plus. So x plus 6 equals 0. X plus 8 equals 0. Subtract 6. X equals negative 6. Subtract 8. X equals negative 8. All right. That is how you solve by factoring. Okay, remember your special factoring rules, and make sure if you are solving by square root, you just get the square root by itself, then take the square root. Make sure you rationalize your denominator. If you're factoring, make sure you use the zero product property to set each factor equal to 0 to solve. All right, if you have any questions, please let me know.